Okay, question number 3 from the Pure Maths 2 P2 IAL Specimen paper. Question number 3, in an arithmetic series, the sixth term is 11, the sum of the first three terms is negative 15. For this series, show that the first term is negative 9 and calculate the common difference. Okay, so it's an arithmetic series. Okay, so we have the first term and we have the common difference, which we have to find. But what we've been given is a sixth term. So we know that the sixth term is equal to 11, and the sum of the first three terms is equal to negative 15. Now, a particular term in an arithmetic series is given by a plus n minus 1 times d. And the sum of n terms is given by the formula in an arithmetic series, n over 2 times 2a plus n minus 1 times d. Okay, or n over 2 times a plus l, first term plus last term, which we probably won't need in this question. Alright, so now what we can do is we can use these two formulae to work out what a and d are, because we're going to have we've got these two pieces of information. Okay, so for the first part of the question, taking into account this, alright, here when n equals 6, then u6 is equal to 11, and this is when n equals 3. So let's take the first part of the information. We know that a plus 6 times minus 1, which is 5. So it's a plus 5d is equal to 11. So that's one equation. And then taking the fact that the third term, the sum of the first three terms is minus 15, we can say n over 2, so that's going to be 3 over 2 times 2 times a plus n minus 1, so that's going to be 2d, okay, is equal to minus 15. Now this equation we can actually simplify. We can multiply both sides by 2 and expand this bracket. In fact, we can multiply both sides by 2 and divide both sides by 3. That will be easier because this is divisible by 3. So if we divide both sides by 3 first, this will become minus 5. Okay. And we're going to multiply 2 by minus 5 gives you negative 10. So 2a plus 2d equals minus 10. And we can go further. We can say a plus d is equal to negative 5. Okay, so we now have a pair of simultaneous equations. We have a plus d equals negative 5 and a plus 5d equals 11. So we can subtract these two equations. We can say 1 minus 2. So we're going to have 5d minus d, which is 4d. Equals, and we're going to have 11 minus 5, which is going to be 11 plus 5, which is 16. So we can say d is equal to 4, and therefore a is equal to minus 5 minus d, which is minus 5 minus 4, which is negative 9. So we've done that. We've shown that the first term is minus 9, and we've shown also that the common difference is 4. Okay, so we calculate the common difference first, and then we show this. We could have actually done it another way. We could have found what d was first, but it's just easy to find what a is first because we have things in terms of a. Okay, then it says, given that the sum of the first n terms is greater than 888, find the least value of n. So we know that n over 2 times 2a plus n minus 1 times d is the sum of the first n terms. So now we know that a is equal to negative 9, and we know that d is equal to 4. So we can use that now in this equation. So we go n over 2 times 2 times minus 9, which is minus 18, plus n minus 1 times d, which is 4. Okay, so what I'm going to do first is I'm going to find out when it's equal to 888, and then we can work out when it's going to be greater than 888. Okay, so what I can do here, I can multiply this out. I'm going to have minus 9n and plus 2n times n minus 1 equals 888. I've just multiplied n over 2 by these two. Okay, so you have minus 9n plus 2n squared minus 2n equals 888. 2n squared minus 2n, yes, so you got 2n squared minus 11n minus 888 equals 0. So now we have to try to solve this equation. I'm guessing that this cannot be solved by factorizing, and n will be some value which is going to be a decimal. So I'm going to use completing the square. Okay, so I'm going to complete the square for this. So I'll say 2n squared minus 11n equals 888, and I'll say n squared minus 11 over 2n, I've just divided everything by 2, equals 444, and then I can complete the square. So I have n minus 11 over 4 squared minus 121 over 16 equals 444. So I have n minus 11 over 4 squared. Oops. N minus 11 over 4 squared is equal to 444 plus 121 over 16. 444 plus 121 over 16. That gives me 7225 over 16. Okay, I'm just going to continue here, although I should really turn over. So I've got now n minus 11 over 4 is equal to plus or minus the square root of this. So let's see what that gives us. The square root of the answer equals, oh good, it's 85 over 4. Okay, so that means n equals, that means it would have factorized actually. That's a bit bad of me. So 85 plus 11 is 95. That's 96 over 4. Okay, that's if it's positive, or you're gonna have minus 85 over 4 plus 11 over 4. 85 plus 85 minus 11 is going to be 74. So that's minus 74 over 4. Well, we can't have a negative term, so we know that it's going to be 96 over 4. 96 divided by 4 gives us 24. So n equals 24. So it's actually the 24th term. It did. All right, so that's when it's equal. That's when it's equal to the least value of n. So the sum of n is equal to 888. Okay, so the sum of n is equal to 888 when n equals 24. Okay, in this case n equals 24, right? So therefore, that's the sum of n is going to be greater than 888. Okay, when n is equal to, now I've got to be careful here because this is the difference is 4. So so it's going to be adding. So yeah, so it's going to be the 25th term. Okay, 25th term. The next term up is going to be when it's going to be greater than 888, because on the 24th term it's equal to 888. So in fact, this would have factorized. This equation would have factorized. We would have had to find two numbers whose product was. It would have been a lot of hassle to factorize it. So using the formula or completing the square is probably easier than thinking of all the combinations. So there's absolutely no problem in doing that. Okay, even if it does factorize and it's complicated, you're perfectly fine doing what I just did now. So we ignore the negative, okay, n number, because n can only be a positive. It's like the first term, the second term, the third term. Okay, the first term of the sequence is the first term of the sequence. You can't go below that. All right. So the 24th term, the sum of the terms is 888. So the 25th term, it's going to be greater than. It's going to be the lowest term, which is going to have a sum for those terms which is greater than 888. Okay. So there we have the answer to that question.